This is a video for AQA Further Pure Mathematics, Matrices section 4.3 using the factor theorem. The factor theorem can be used to check whether an expression is a factor of a determinant. So for example, if we have a minus b that we want to check whether that is a factor, then all we need to do is to make a equal to b in the determinant and show that that then makes the determinant equal to 0. Obviously, if we've got a minus b with a equal to b, then that implies that a minus b is equal to 0, and therefore that would make the determinant equal to 0. So substituting an expression in the determinant and showing that determinant equals 0 is sufficient to show that that we have a factor of the determinant. So as an example of that, I'm going to show that x minus y and x plus y plus z are both factors of this determinant delta. And then once we've done that, we can express delta as a product of its factors. So the first part, I need to substitute x equal to y. So if x equal to y, then that will make delta equal to the following. It will be y, y, z on the first row, y, z, and y squared in the second row, and then in the third row, y plus z, and 2y. Clearly the first two columns are equal to each other, so if we now take column 1 and subtract from it column 2, then delta becomes 0, 0, 0 in the first column, and then obviously the other columns remain the same. But once we've got a column equal to zeros, then that means that delta must be equal to 0, and hence we have that x minus y is a factor. In the second part of the example, we wanted to show that x plus y plus z is a factor, and therefore if we substitute x equal to minus y plus z, then that should give delta equal to 0. Well, if we do that, you can see that delta becomes this matrix, this determinant here, and again we have rows and columns that are equal to each other. So this time the first row is negative of the third row. So we can this time add row 3 to row 1, and the first row becomes 0, and hence delta is equal to 0, the determinant. So we have x plus y plus z is also a factor of delta. So you might want to just pause the video and check through that and make sure you're happy with the idea, but it's just substituting x equal to negative y plus z. Well, now that we know two of the factors, those same row and column operations that we used to prove those factors can be used to start factorizing the determinant itself. So firstly, we know that x minus y is a factor, and we got that by subtracting column 2 from column 1. And if we do that, column 2 minus column 1, we can see that delta will be equal to x minus y, y, z in the first row, and then z times y minus x, and zx and xy in the second row, and finally y minus x, x plus z, and x plus y in the third column. Now we've then got a factor of x minus y in the first column here, so we can take that out, x minus y as a factor, and we're left with 1 y z in the first row, negative z, zx and xy in the second row, and negative 1 x plus z and x plus y in the third row. And you can now see that if we add row 3 and row 1 together, then we're going to get the other factor, x plus y plus z. So we subtracted column 2 from column 1 to get the factor x minus y, and if you add row 3 to row 1, you can see now that we get a factor in the top row of x plus y plus z. So we can take that out as another factor from the determinant. Well, let's do that now, so that the determinant is now x minus y, and we've got the factor x plus y plus z coming out from the first row. So that becomes 0, 1, 1, and obviously the other two rows stay the same, negative z, zx, xy, negative 1, x plus z, and x plus y. Now, all sorts of ways of then evaluating the determinant that's left, but one way would be to subtract column 3 from column 2, so that we get x minus y, x plus y plus z, and then when we do the subtraction, we get 0, 0, 1 minus z, and then x multiplied by z minus y, xy, and then finally negative 1 z minus x, I beg your pardon, z minus y, and x plus y. Now that is then a relatively straightforward determinant to evaluate, because we've got two zeros in the top row and just a single element here of 1. So just looking through that again, we've taken out the two factors that we knew about, and then you could see that subtracting column 3 from column 2 would produce a 0 here. And then we have, at this point, a nice easy determinant to evaluate, and you can see that we get then minus z and z minus y. Well, we could actually factor out, I beg your pardon, the z minus y from here, leaving us with this matrix here to evaluate. And the determinant of that is given by the x minus z. So in total we've got there the 4 linear factors of the determinant. Well, that's the end of this video on factorizing determinants, and indeed end of the series of videos.